Hi, everyone. My name is Aaron, and I'm a co-founder of Clotho. Today, I'll be demoing the latest capabilities of InfraCopilot. InfraCopilot is an intelligent infrastructure design tool that understands how to define, connect, and scale your infrastructure as code. It makes it simple to provision and edit infrastructure without having to look up specific cloud details. When using it, you wouldn't need to go to a cloud engineer or DevOps folks every time you're trying to make a change, small or large. Today, I'm going to be showing off our broadened Kubernetes support. And to do so, I'll be running a number of queries that will create an interaction with Kubernetes cluster. On the side here is these queries. You can see that it's everything from creating the cluster itself to provisioning some pods to connecting them to various AWS resources. So with that, let's kick it off. The first step is right here. Set up an EKS cluster called EKS Cluster 01 for hosting your Kubernetes infrastructure. So we will come to InfraCopilot, start ourselves a new conversation, and let's go ahead and enter that query. And there we go. Some things that we're visualizing here, you'll see that we have the EKS cluster 01. We're also showing the VPC in which it resides. What's not shown here is everything else that is created as a side effect of infrastructure. There's things like IAM policies, subnets, and more. This visualization is really just meant to show the data flow and how things are traveling throughout, and that will be reflected throughout the rest of this demo. So let's go to our next query, which now we want to create some pods and services running inside of this Kubernetes cluster. So we're going to be creating 4 services: video service, channel service, comment service, recommendation service, and authentication service. So excuse me, 5 services. Paste that in. And there we go. You'll see now that the Kubernetes cluster expanded to be a boundary. All of these pods live within that boundary. Currently, they're not connected to anything, so we're showing this disconnected resource icon. But we will fix that in a second and connect these to some things. Let's go back over to our query. The next thing we'd like to do is establish connections from all these pods to a single RDS instance that we're going to call UserDB, which will be used for database operations. Great. And now you can see that all 5 pods are connected to this UserDB RDS instance. You'll also notice that the RDS instance lives within the same VPC, which is how this connection is able to be established. And I mentioned before data flow. So right now the traffic is coming from the notification service to the database. So that is how the connection is established. Next, let's create an S3 bucket called video storage, which we're going to use for storing our video files. And also we'll connect that to our video service pod so we can make use of it. There we go. You'll see that that created our S3 bucket. It is outside of the VPC, but we're able to establish that connection anyway, which means if a VPC endpoint was needed or something like that, that is also here, although it's not represented in the data flow diagram. Next, let's add caching to our channel, to our video and our channel services. So we're going to be adding Elastic Cache instances to both of those. So you can see here now that we have the 2 caches connected to their appropriate services living within the VPCs. And the last thing we want to do is really expose this entire thing to the internet. So we want to route an API gateway to all of these services. As you can see here, we're just creating an API gateway called API Gateway 01 and just connecting it to every pod. Awesome. So now you can see our API gateway is being routed to these pods. You'll also notice that there was a side effect that was added here. This time we're including it in the visualization since it's part of where traffic is going. The API gateway actually routes to load balancers, which then route to their appropriate services. So now that you've spent time and completed architecting your application, the last little bit is to make it a deployable artifact. So what we can do is we can go to Actions and click Export Pulumi IAC. To note today, Pulumi is our only IAC we support. Terraform will be coming soon. But if you were to click this, you would get a deployable version of the infrastructure as code based on your diagram, including parts that aren't shown in the diagram. So IAM roles, subnets, anything else that's needed to make this wiring work. The control flow here dictates things like how IAM policies work. So the video service, for example, would be the only one who has an IAM policy to talk to the video cache. Additionally, we would generate any other necessary artifacts for the Kubernetes cluster, including Helm charts, and we'll explore this in future demos as well. With that, we've finished showcasing the latest updates to Kubernetes. With more support to come, you now have access to create EKS clusters, pods, the ability to connect those pods to other AWS resources, all as part of your architecture. Thank you very much for taking a look.